integration chapter. Where's my pen? Okay, so you need to, as the specification requires, you need to understand that integration can be thought of as the limit of the sum of f of x delta x. So this is not something you need to prove, but you need to understand, and you need to be able to use it as a command as to, here's the limit integrated. So let me just find the part from the formula booklet. So how's it worded? Well, it's more from specification. I think it might be hiding underneath here. Okay, so the specification will say that you need to understand and use integration as the limit of a sum. So you need to recognize that the integral between the two limits a and b of a function can be thought of as the sum of f of x, so your y's, delta x multiplied by delta x, which is the width of each strip. I'll show you on the picture what I mean by it, as each width of the strip tends to 0. So you may be asked to calculate the limit for a given function, and then when it asks you to calculate this limit, they are asking you to simply find the integral. Okay, so, and obviously we've got, if you could see that the starting value is a, the end value is b, and these are your lower and upper limit of that integral. So if you imagine the picture, so this is your function f of x, so there is the curve. As you can see, we are going to find the area of the space under the curve between the two limits a and b. We know we are going to use the integration to find it, so this area can be thought of as the integral between a and b of the f of x dx. But if you were going to physically try and find this area, you can think of as breaking it up similarly to what you did in the trapezium rule, but this time breaking it up into tiny rectangles. So you've got one here drawn on the right hand side. Okay, so that rectangle of width h or delta x. So remember we used h in in the trapezium rule and h in differentiation. Now it's going to be like that. Okay, so it's that strip. But obviously as this strip gets smaller and smaller, you are going to have a nicer fit underneath the curve. Okay, so and then the sum, because you will have lots of these strips, so you're going to imagine that this rectangle here has got the height is equal to the y coordinate, which is your f of x, and then the width is delta x. Therefore the individual area, okay, is going, let's call it delta area, is that f of x multiplied by delta x. Okay, now if you have lots of them and add them together, overall you're going to get the area under the curve. Okay, so the total area is going to be approximately equal to the sum of lots of those strips. Okay, starting from A, finishing at B, and it's lots of y's multiplied by delta x. Okay, now if you want to be more accurate, you're going to make that delta x tend to 0, so make them so tiny, almost you can't measure the width of it, and you have loads of them, infinite number of them, in fact, and you can write it mathematically as the limit of this sum as delta x tends to 0. So that's where this notation comes from. And you don't really need to know necessarily all that proof. You just need to understand that this here means integrate. This means find the area under the curve. Okay, so let's have a look at the example. Where's the example? I think it's here. Okay, and then the actual exercise will have only 3 questions. Okay, so the diagram shows a sketch of the curve with the equation y equals sine x, and the area under the curve between x equals 1 and x equals 2 can be thought of as a series of thin strips. Okay, so we haven't got that, so let me just quickly take it from the not here. Okay, let's just copy this one quickly. So there's the diagram. No, that's from there's the diagram. Okay, so just quickly copy this. Okay, so this is this diagram that the text is talking about. There you go. Okay, so now it says simply the area under the curve between x equals 1 and x equals 2 can be thought of as a series of thin strips of height y and width delta x. Calculate the following expression, the value of that following expression. So as you could see very quickly, this is the sum of those strips, and we're going to look at those strips as the width of them tends to 0. This is our definition of the integral. So we are asked to find the value of the integral of sine of x dx between the limits 1 and 2. So sine integrate to cos minus cos x between the limits 1 and 2. So we are going to write it as minus cos 2 minus cos 1. Remember, you need to put the values of, so that's cos 1 minus cos 2 of 1 and 2 are radians. Okay, so pop it into the calculator and you should get the answer of, let me just find it for you, of 0.9564 to 0.9564 to 4 significant figures. Okay, so there you go. Hopefully that concludes perfectly chapter